Hello, my dear viewers. Today I am before you to take the first lecture class regarding the keynotes of the board examination questions. In this class, you just want to know what are all the main points related to the examinations, competitive examinations, which you must know. I will make you acquainted with all that. What are all the probable questions which are coming from that area? I have arranged all these study material. Just take a note of all these things because the main questions which will check out your acquaintance of this topic will come from the areas which I have covered from the chapter 1 solid state in the chemistry +2 chemistry solid state unit 1 which will be based on the NCERT text. So in every class, I will try to can incorporate a board examination question also, because each and every my videos you will get profit. It will be profitable to you. Just I have covered minimum. I will cover one or two board examination questions. So support me, like, share, and subscribe my channel, PCM Guru Bro. This is the first lecture regarding the +2 or class 12 CBSE, ICSE, or state board +2 HSE level. The chapter in the chemistry unit 1, which is based on the solid state. So the unit itself is about the solids characteristics and classification of solids. Solid is something which is among the three states of matter. So the three states of matter are solid, liquid, and gas. So this is the firm thing. So the characteristics which are dealt in this chapter and the classification of these solids. So even in the even when the examination gets very simpler, these general characteristics are also asked in the examination. So if they ask the general characteristics of water, or which is asked in the solid state this chapter, then just write the general characteristics of the solids are it have a definite mass, volume, shape. Okay, mass means kilogram, and volume meter cube, and a shape. Solid has a certain shape, like these shapes: tetrahedron shape, cubic shape, everything. So like that, it has a definite mass, volume, and shape. And then comes the molecular force, the strong intermolecular forces, in solids, which is composed of molecules, they have a strong intermolecular force, and these solids behave very rigid, so the 3 points which I have depicted in the star by bullet point stars, so just take a note of all I have giving you by these notes, try to download or see this um, whiteboard description manuscript in the maximum clarity possible, because I have recorded this in the 4K format. I have, if I compress, it will never lose the quality also. So just see in the maximum quality possible. So I will also explain what all is written in this also. So understand very well. These are all the examination key points to be noted. So by now we have discussed the 3 points. The general characteristics of a solid is a definite mass, volume, and shape, and the molecule is having strong intermolecular force. They are rigid, and the constant particles are positioned in fixed positions and can only oscillate with respect to mean position. The thing is that, first of all, a definite mass, volume, and shape, and then strong intermolecular force, and they are basically rigid, and the constituent particles are arranged in fixed positions, and they can just move according to a mean position only. If this is placed in a mean position, it can only move with respect to a mean position. That is what is written on the. So the points to be covered are definite mass, volume, and shape. The molecules, there is strong intermolecular force between them. They are rigid, and the constant particles, there is a they are positioned in a fixed positions. The constant particles, molecules, atoms, they are positioned in a fixed positions and can only oscillate with respect to a mean position. That's it. They can only oscillate with respect to a mean position. It will oscillate. This is the main position. It will oscillate like this. So this is the general characteristics. Just note that even if it is when it is asked in exam, just write all these basic points. Then comes the real thing, which are all in the examination: the classification of solids. Okay, the classification is based on how these particles are arranged. Earlier we have said about a particle which are positioned, no, which can oscillate with respect to position. How these oscillation causes, because when we apply heat or electricity, no, that causes the vibration. If gamma rays also is given, the water molecules vibrate. Okay, that's it. So these are all the things. The particles, molecules vibrate with respect to particles vibrate with respect to a fixed position, a mean position, and on the basis of how the constant particles are arranged. The constant particles, no, their arrangement gives rise to the classification of solids. Thus, the solids, basically these solids are classified into amorphous and crystalline. By the name itself, no, crystal, that means it will be shapy. Crystally, that means it's what are all crystals you have seen, glass, something in the fancy stores. Crystalline, that means it has some shape, a very good shape. But this morph means without a morph, that is amorph, that means without a shape. That is without a shape and with shape. These are the two things. So according to the basis of how these particles are arranged, the solids are classified into the without shape and with shape. That is amorphous and morph. Oh, no, that is crystalline. Morph and amorphous and crystalline. Not that, no. Earlier a question is asked: the crystalline solids have sharp melting point because the arrangement is very orderly, no. So they have sharp melting point. That's a characteristics of crystalline solids. Here, the crystalline solids are again under consideration. So the crystalline solids are divided into 4 types of crystals. These are asked on the board examinations earlier. What are the 4 types of crystalline solids? That are: first is molecular solid, then ionic solid, metallic solid, and covalent solid. Here, the covalent solid is otherwise called network solid also. Here, no, I will make you understand just by just mic, which I microphone mic. Then MIC, molecular solid, ionic solid, and covalent solid. Okay, in the crystalline solids now these are involved, and then again one M comes, mic M. Okay, MICM, that is molecular solid, ionic solid, covalent or network solid, and then metallic solid. Is in the mind, no? Mic M. This is the acronym to understand this. The memory trick to understand that. So again, not a point. One question is: these molecular solids are constant particles are solids? These are all okay, are solid. Just a IC chip are solid state. IC chip is a solid state circuit. This is an objective type question earlier asked in the entrance. IC chip is a solid state circuit. With the metallic solid, semiconductor solids or solid state circuit. IC chip is a solid state circuit, not this. Just if it is asked, that will be useful. Next, a molecular solid is further defined. This first thing, no. First of all, you just want to know there are 2 types based on the arrangement of the particle, that are amorphous, that is having a different amorph, not shapely, and shapely. Shapely means crystalline. And then this crystalline is further divided into 4, that is mic M, that is molecular, ionic, covalent or network, and then again metallic. Okay, let the metallic be at the last. Molecular, ionic, covalent, and then metallic. So this molecular solid, first of all, this molecular solid is further divided into non-polar molecular solids. What is non-polar? Hey, we know earlier this North Pole and South Pole, no? Likewise, positive and negative, no? So if there is a non-polarity in these molecules, no? If the molecules are there, whatever there be, water molecule or, okay, sodium, these things, sodium chloride, which I will teach you later. Okay, this thing. These are having polarity, a positive sign and negative sign. This There are certain solids, molecular solids, which are non-polar. There is no polarity of charge. So these solids are basically termed non-polar molecular solids. And then comes the polar molecular solids. Okay. And then comes the hydrogen bonded molecular solids. These are the three molecular types. That is polar, non-polar, non-polar, polar, and hydrogen bonded molecular solids. So in coming to the first thing, non-polar molecular solids, the basic characteristics are they are soft, they are non-conductors. Non-polar means they are soft. Basically not this. We can connect and again by heart all these things. Non-polar solids, they are in the molecular solids, in the non-polar molecular solids, it is soft, it is a non-conductor of electricity, and the constituent atoms or molecules held by weak van der Waals forces. That means the uh, the atoms or molecules, which is comprising in this molecular solids, they are held together by van der Waals forces. That is in non-polar molecular solids, the weak force is acting. That is van der Waals forces acting, and these molecules are in a small discrete arrangement. So again, telling the way. Non-polar molecular solids are soft, they are non-conductors of electricity. Constituent atoms or molecules are discrete arrangement of these held together by the weak van der Waals forces. That's why this soft thing, non-conductor, is having low melting point. That means it will melt easier because weak van der Waals forces is acting inside. That's why low melting point. This should be connected. This will be useful in exam. In the molecular solids, the non-polar molecular solids are having low melting point because there are weak van der Waals forces. Not this. Okay, that's enough. Then polar molecular solids. This polar means I had earlier said no, it is having north pole or south pole. No, it is not of magnet or something, but positive and negative. Here, uh, the molecules are there. It is having polarity, the charge polarity. What is that? Held by relatively strong dipole-dipole interaction. What is a dipole? Basically, a dipole, no, is a positive and a negative charge which are together, and they comprises of the basic constituent of these molecules. Okay, so these positive and negative unit, positive and negative unit joined together is called a dipole, and these dipoles, interact with each other. So in the polar molecular solids, there are dipoles, and this solids in which it comprises of these dipoles are held by relatively strong dipole-dipole interactions in this polar molecular solids. Okay, understood. For what I am saying in the fast manner, it is just the point. Just understand these are the examination points which you should write. If I take a long class, it will not be beneficial for you. Just these are the examination points. You can just add on gas on it and write it in the very best manner by each and every talent which you have. That's it. So in the molecular solids, non-polar molecular solids are there and polar molecular solids are there. The non-polar thing contains van der Waals forces that will result in low melting point, and the polar molecular solids, it is in this the molecules and the molecules or particles are held together by strong dipole-dipole interactions. Okay, dipole means a positive and negative charge joined together, and many such things are there, and their interactions will give rise to strong dipole-dipole interaction. The hydrogen bonded molecular solids is the third thing in the molecular solids. Hydrogen bonded molecular solids is held by hydrogen bonding. The name itself now is given like that. Hydrogen bonded molecular solids are included in the molecular solids, which are held together by hydrogen bonding. Here, just one question was asked: what is the bonding in the ice? Okay, that is intermolecular hydrogen bonding. Strong hydrogen bonding is in the ice. So hydrogen bonded molecular solid is ice. Okay, they are soft solids under room temperature and pressure. At the room temperature and pressure, no, these are soft solids. Okay, so basically, I will say once again, these molecular solids are divided into three: non-polar molecular solids, polar molecular solids, and hydrogen-bonded molecular solids. Non-polar molecular solids are soft, non-conductors, consist of discrete small atoms and molecules held together by van der Waals forces, which will give rise to the low melting point. Polar molecular solids are held by the strong dipole-dipole interaction. Hydrogen bonding molecular solids are held by strong hydrogen bonding, exemplifying the ice. And the soft solids, these are hydrogen bonded molecular solids, are soft under room temperature and pressure. Then we can leave the molecular solids. The first part we can leave. Then comes the ionic solids. What is ionic solid? The ionic solids, no, the constituent particles and particles are ions. The name itself gives, no, ionic solid means constituent particles are ions. And then again, they are hard and brittle also. Look, here example is NaCl, that is salt, now common salt, which will give rise to the ionic form, the sodium ion and the chlorine ion. So this ionic solid constant particles are ions, sodium ion and chlorine ion, and it is in an ordered fashion. Okay, plus and minus in the ordered fashion. It is hard and brittle. Okay, salt is brittle and hard, and it has a high melting and boiling point. Okay, ionic solids is the characteristics of high melting point and boiling point, and a strong electrostatic force is there. You know that this is charged, no? This is charged, no? Sodium is charged, chlorine is charged. So there will be a strong electrostatic force between these two, sodium and chlorine ion. That's what we have to learn from ionic solids. Then comes the metallic solids. Metallic solids, no, all metals are included in the metallic solids. They have high electrical and thermal conductivity. The electricity is conducted very easily. Thermal, the heat energy is conducted very easily. And metallic solid, no, there is a orderly connection of positive ions. No, there is a order that positive ions are arranged very orderly. The positive ions here are otherwise called kernels, and these orderly arranged positive ions are surrounded by free electrons. Okay, this positive ion is surrounded by free electrons. This is the basic characteristic of metallic solid. All metallic solids include metals, the high electrical and thermal conductivity, orderly collection of positive ions. That is, positive ions are otherwise called kernels and surrounded by free electrons surrounding the positive ions. Okay, that's it. Metallic solids. Just remember this because we will go deep into in the which is asked in the question. Metallic solids. Describe give a note on metallic solids. That I will give you. This is the main thing which is asked frequently. And then covalent network. This is the thing which has to be said, but just to explain it more. That's it. Read also the text and all notes which you are given. Then comes the covalent network solid or covalent or network solid. This is the fourth thing. By this it is finished. Okay, covalent or network solid. Covalent or network solid is in which the atoms are held strongly at positions. That means covalent or network solids, the atoms are strongly held at positions. And they are basically insulators. Insulator which will not allow heat or electricity to pass through. And example is diamond. Just if you hear the mic I have said earlier, no, the shrinking form, molecular ionic molecular ionic covalent network or and then metallic. Okay, so if you hear the covalent or network solid, then first of all remember this diamond. Diamond is covalent or network solid. It is an insulator which does not allow current or electricity to pass through. Atoms are held strongly at positions. That is what to be remembered in this section. This is easy here. Just visualize what all I have said and just go for exam. That's it. Write well. And a very important question in the examination is asked. It is I do not know whether it will be, but just note this: quartz. How can we convert quartz into glass? A simple question, 1 mark or something. So just note that this quartz is melted, no, and then cooling rapidly. The quartz can be converted into glass by melting and then cooling rapidly. That's the thing. quartz into glass by just melting and then cooling rapidly. Just melt it. The quartz is just melted and cool it very rapidly. Then this quartz is converted into glass. That is the board examination question once it is asked. So again, we will come again to brush up all these things. That is, solids are classified into on the basis of the arrangement as amorphous and crystalline. This is having no shape. This is shapy. This shapy crystalline is divided into four things: molecular, ionic, covalent or network, and then metallic solid. Then this molecular, again, the first thing is divided into three: non-polar, polar, and hydrogen bonded thing. This non-polar is soft, and hydrogen bond is medium, and this polar is very strong. Okay, that's it. Relatively strong. And this is okay. This is strong by hydrogen bonding. Polar is by strong dipole moment. Hydrogen bond is by hydrogen bonding, and non-polar is by van der Waals forces. Just remember all that. And just remember, this non-polar molecular solids are having low melting point by weak van der Waals forces. And just the second thing, ionic solid, again, these constant particles are ions, and left water all. These ions have strong electrostatic forces and brittle, high melting and boiling point, everything, ordered arrangement. Then the metallic solid, which is consisting all metals, high electric and thermal conductivity, positive ions or kernels have orderly collection surrounded by free electrons. And then the covalent network solid, in which atoms are strongly held at positions. Example, diamond, it is an insulator. That's it. And a quartz can be converted to glass by just melting and then cooling rapidly. That's the thing. Okay. And then metallic solid comes. Metallic solid is frequently asked. So just go through what are all main points you want to remember. It is a metallic solid is an assemblage of positive ions immersed in a sea of mobile electrons, which I have said earlier. No, I have reiterated in another manner. That means a sea of mobile. There is a electron sea. Okay, in that positive ions are immersed. That means, write well, an assemblage of positive ions immersed in a sea of mobile electrons. And then each electrons belongs to a number of positive ions, and each positive ions belongs to a number of electrons. Okay, that's the second point. And the force that binds the metal ions to number of electrons. The force which binds the metal ions, no, metal ions are there, which is to be binded to the number of electrons within its sphere of influence. This metal ions have a sphere of influence, no? Within that, the force which binds the metal ions to the number of electrons is called metallic bond. So metallic bond is the force that binds the metal ions to number of electrons within its sphere of influence. That's the thing to be beheaded. And then this force, no, it's a strong force, so good conductors of heat and electricity. So by the metallic bond force, no, it's a good conductor of heat and electricity. It's having sharp melting point and sharp boiling point. And the free and mobile electrons are responsible for high electrical conductivity. These free electrons, the C which I have said earlier, no, which is interacting with the metal ions, no. So they are responsible for high electrical conductivity. That's the main thing. So note these points which are to be said about the metallic solids. That's enough. Okay, then comes the crystal lattice and unit cell. This is the area where a solid is comprised of a repeating units. Like that, a wall is comprised of bricks. Like that, in the world of solids, there are some bricks. So in that we can call that brick a crystal or space lattices. Okay. The bricks are called crystal and space lattices. The regular arrangement of constituent particles. These are let it be this is the brick. These are arranged regularly. So the regular arrangement of constituent particles is comprising this crystal or space lattices. The atoms, ions, or molecules are what which is said. So the regular arrangement of constituent particles of crystalline solid in 3D space. It is not 3D like which we can write. It's a 3D, three-dimensional, x-axis, y-axis, and z-axis. So these crystal or space, this space is defined in 3D space, and the crystal is having a three-dimensional quality, So the regular arrangement of a certain constituent particle of this crystalline solid in 3D space. In 3D space, it is arranged. That's the essence. Crystal or space lattice is about the study of regular arrangement of constituent particles of crystalline solid in 3D space. Then what is a unit cell? This is the smallest repeating pattern. This is the repeating pattern. This can be the repeating pattern. This can be the repeating pattern. Unit of a crystal. So the unit cell is the smallest repeating pattern or unit of a crystal. In a crystal now, the smallest repeating pattern. The smallest repeating pattern of a wall is a brick. Now, like that. The unit cell is the smallest repeating pattern or a unit of a crystal. That's it. So this unit cell is having primitive unit cell and centered unit cells. In the primitive unit cells, now constituent particles at the corner positions. Primitive unit cells have constituent particles at the corner positions. And the centered unit cells, now, in addition to these corners, now, one or more constituent particles are present. Here, look at it is in the middle of this whole cube. Now, here it is arranged in the sides, but only half is included inside that cube, isn't it? Likewise, centered unit cells are in which, apart from this, in addition to these corner things, no, some is included inside the cell, in the faces or in the body, inside the body. That's it. So, coming clearly to what we want to study, in the crystalline space lattices, regular arrangement of crystalline solid in 3D space. Okay. Crystalline regular arrangement of constant particles of crystalline solid in 3D space. Unit cell are consisting of primitive unit cells, which are just in the corners, but in the centered unit cells, in addition to these corners, there are particles inside the center, in the center or at the faces, in which half is included inside that cube. Okay, that's it. So these three are the basic three figures which you want to study: the simple closed packing structure, the body-centered closed packing structure, and the face-centered closed packing structure. In this, now look at this. If a sphere is taken, now when we cut that into two parts, what we will get? Okay, what we will get? A sphere, when we cut into half, we will get a hemisphere. Now from that hemisphere, now a quarter is taken. Okay. That means 1 by 8 of a sphere is included in this section. 1 by 8. 1 by 4, half is taken away. Okay. And then remaining is half. In that half, it is taken 1 by 4th of that half. That is 1 by 2 into 1 by 4. That is 1 by 8. That means 1 by 8 of particle is inside this cube over here. So, like that, 8 corners are there now. So 1 by 8 into 8. That is, in the simple cubic packing, a particle involved is 1. In the case of a body-centered cubic packing, no. Just remember, along with this 1, no, a single is in the middle. A single particle is in the middle. So 2 particles are included. That is 1 by 8 into 8 plus 1. This is asked in the exam. So just remember. That means at the corner, no, when we divide, half it is there. From that half, 1 by 4 is taken. So half into 1 by 4, that is 1 by 8. And each 1 by 8 into 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. Is equal to 1 by 8 into 8. That is simple closed packing is equal to 1 particle. Body centered cubic packing is equal to 1 by 8 into 8 plus 1. That is 1 plus 1. This thing. So 2 particles are involved in body centered cubic packing. And then comes this face-centered cubic packing. In this face-centered cubic packing, just look at this. It is just like idli. Just consider this whole thing to be a sphere. No, this whole sphere can be divided into 2 parts. One, just this plane cuts this sphere into 2 parts, and this cut this whole sphere into 2 idlis. Let the one idli is inside and the other idli is outside. No, just like that. Think about it. So the what will be the amount of particles inside at each faces? No, half is inside. So what are all? There are 6 faces. 6 faces into half included of each. So 3 particles are from these faces, and again at the corners there is 1 particle. So 1 plus 3, that is 4 included. This is the explanation. Just write it well by giving your own sentences. That's what it. The number of particles included in the face-centered cubic structure is at each corners 1 by 8 is involved. So 8 such corners are there. So 1 by 8 into 8 is 1. And at each sides, half is involved inside this cube. So such that 6 faces are there. So half into 6. That is 3. So that whole 3 plus 1 is equal to 4. That is 4 particles are involved inside the face-centered cubic packing structure. So this centered cubic structure, which I have said earlier, now it is consists of 3 types. That is simple cubic at the corners of the cube, the body-centered cube at the corners plus center of the cube, and face-centered cubic packing structure, corners as well as at the center of 6 faces. Okay, is it clear now? By now, you just write it by your own sentences, but write it very neatly, very beautifully. And as far as my each and every video, just we can discuss a board examination very important question. That means, first of all, I want to make you acquainted. I will make you that much level easier things. This is a shape called a tetrahedron. This tetrahedron is made by how let this be at the corner of a triangle. Let like this be like this. Okay. This is the thing. And again, here is a sphere, here is a sphere, and here is a sphere. And again, another sphere is put on the top. Okay. That is again, this is the side view and this is the top view. Okay. When we see like this, this red thing is the another sphere. Okay. It is placed on the top. Okay. But when it is seen this side, look at this. This in the top and these 3 things. Okay. These 3 things and this thing is in the top. Okay, so the void, the space inside this, it is called the tetrahedral void. That's the meaning. And we can solve this question. The thing is, in a binary compound, that means binary means there are 2 constituents, A and B. Okay, in a binary compound having a cubic unit cell. Okay, it's having a cubic unit cell. So just like this, cubic unit cell. And the anions B are located at the corners of the cube. Anions, that means negative charge ions are at the corners. That means 1 by 8 into 8. Okay, that's enough. And corners of the cube, in a binary compound having cubic unit cell, the anions B are located at the corners of the cube and the face centers. Oh, along with this corners, also face centers are also this. It's in a binary compound having cubic unit cell, the anions B. These anions B are located at the corners of the cube and the face centers. This B is located at the corners. B is located at these corners and along with the face centers. Okay, this B is at here and this B is at the faces also. Along the corners and at the face centers. So these are all B. Look at this picture. This is B, this is B, this is B. Everything is B. Then it is asked, in a binary compound having cubic unit cell, the anions B are located at the corners of the cube and face centers, whereas cations A occupy all the tetrahedral voids. Cations, that means positive charge ions are A and they occupy tetrahedral void. What is the formula of the compound? Okay, when this question comes now, then how much number of atoms are B atoms? Just to consider like this thing now. At the corners, B is 1 by 8 is involved at each corner. No? So 1 by 8 into 8. 8 such corners are there. Plus at the 6 faces, B are there. No? So half of B is involved at 6 faces. So the B particle is 4 number. Okay, B particle is 4 number. And it is given in the question that what will be tetrahedral void, isn't it? Okay, tetrahedral void, then just in the case of tetrahedral void, twice the particles are involved. That means, first of all, we will calculate about that number of particles involved by the cubic structure. No, twice that is involved in the tetrahedral void. That means the particles involved in the cubic structure is 4 and that into 2 is the atoms of which are in the tetrahedral void. Okay, that is 4 into 4 twice. That is 4 into 2 is equal to 8. That means B4 and A8. This is the thing. Another way to solve is that look this figure clearly. These everything is just here. This is the corner, and inside this 3 is involved. Anyway, 3 particles are involved inside. This is acting like this. So for every corner, every corner 1 is there. A particle is there. So what are all corners are there? 8 corners are there. So according to each 8 corner, 8 particles are involved in the tetrahedral void. This is the another explanation. Okay. So first of all, by heart, this is the peak point inside this tetrahedral void exists, and consider this to be the point, the peak point, and such that 8 corners are there. 3 are inside. So in the each tetrahedral void, according to each at the corners, 8 things are there. So we can get 8 answer here, or in the mathematical statement we can say that in the case of tetrahedral voids, twice the particles involved. That means the particles involved are 4 into 2. That is A8B4. This is the original molecular formula. That means A8B4. But further simplified now, it is to the empirical form. This now 4 and 8 get cancelled out. A2B1. That is A2B, which is written over here. That is empirically A8B4 molecular formula can be written as A2B empirically. So just another note is that every single corner atom is involved to 3 atom inside this cube. So that will comprise of a tetrahedron. So each corner, single corner atom, is depicting what are all void inside. So if there are 8 corners, then 8 voids are there. Inside that 8 particles are there. So the sentence goes like this: every single corner atom involves 3 atoms inside the cube. Thus, tetrahedral void is consisting of, according to these 8 corner particles, is 8 particles. Okay, this is complete. I will continue with the next